Okay, in this video, we are going to go through the second part, the B section. So there's 300 marks in total for paper 1. This section is worth 150 marks, so 50%. There is a choice here. You can do 3 out of 4, but like always, I would be saying we should be doing 4 out of 4, and the examiner will pick our best 3. Okay, this is question 1. Paula participated in a javelin event at a track and field competition. The height of the tip of the javelin in meters above the ground after it is thrown can be modelled by this function. Okay, now when I look at this function, I can see it's a squared function, and it's actually a minus squared function. Now it is minus t squared, but that's the same as calling it a minus x squared. All right, they've just changed the letter. And so the shape of the graph looks like this, okay? That would make sense with Paula throwing the javelin, okay? It will rise up and then gravity will pull it back downwards. So work out the height of the tip of the javelin in meters above the ground when it is thrown. Now they give you a massive hint here, is they say t is 0. Remember, t stands for height in meters. So work out the height in meters above the ground when it's thrown if t is 0. So you are just putting in 0 here. Minus 4.9t squared plus 19.6t plus 185. Now, sorry, 1.85. If t is equal to 0, that would be minus 4.90 to be squared plus 1.96 times 0 plus 1.85. They're going to cancel out and you're going to be left with 1.85 is your answer there. Solve the function h of t equals 0. Okay, so solving questions means give me an answer for t. If you look at this, right, you have got a squared and a t. So normally, if we were looking at something like, say, x squared plus 4x plus 3 equals 0, and I asked you to solve it, you might talk about, or you might think about quadratics. They've just replaced this with t, okay, in this instance, but the numbers are much more complicated, okay? They've given you a massive hint here where they say, give your answer to 1 decimal place. So how you're going to solve a quadratic when you don't know the factors is you are going to use your minus b formula. In order to get an attempt mark on this question, you needed to write down the minus b formula, which is on the front of your log tables, and then you needed to say what your A, your B, your C was and do some substitution. So A is equal to the number in front of the t squared or the x squared. That's your A. So in this case, it's minus 4.9. Your B is the number in front of the letter on its own. So in this case, it's 19.6. And your C is the number on its own. So my C in this case is 1.85. All right, I'd have expected everybody to have gotten that. We have looked at that very recently, okay? I want you to solve it all down. When you solve it all down, you're going to get 2 answers. Obviously, one will be a positive, one will be a negative. You're asked here to find the time taken. So time can never be negative. All right, we can't go back in time, so it'll be the positive answer. Make sure you give it to 1 decimal place. I want you to finish this off now, and your answer should be 4.1. Okay, this next part asks us to complete the table to show the values of h of t. Now, what I've done is I've just written down what h of t was. It was on the previous page, but just to have it there beside me. So if h of t is equal to minus 4.9t squared plus 9.6t plus 1.85, if t is 0, what would the value be? If t is 0.5, this should be the value, and so on. So we are substituting in these values into this. We can do it the long way, that's absolutely fine, or we can use the function button on our calculator, clicking into define f of x. You will notice that this is a t squared. We don't have t's in here, so you're going to have to refer to it as x. So you would be typing in minus 4.9 x squared plus 19.6x plus 185. And then for your inputs, these are the numbers that you're going to put in. So you're moving in 0.5. And the calculator will do all of that work for you. If you want to take it a bit slower and you're not too comfortable with that, you're simply placing in 1.5 here everywhere you have a t. Okay, so in this case, it would be t squared. Make sure you keep your brackets and everything perfectly. Okay, I'll give you a few answers to this. Okay, 21.45 should be the answer for this one. And 1.85 should be the answer for that one. I need you to fill out all of those yourselves, and then you're going to graph it, okay? So remember, along the corridor, up or down the stairs. So I will graph this one here for you, 0.5, 10.43. We go along at 0.5, we go up as far as 10.43. So something a little bit like that, okay? I'm expecting everybody here to complete this table and sketch that graph perfectly. The next part is use your graph to estimate the length of time the tip of the javelin was 15 meters or more. So 15 meters or more, this is the height here. This is where the graph is 15 meters or more. So I'm imagining that your graph looks something like this, all right? That's only very rough. But for how long would it be above 15 meters, okay? So what the examiner is looking to see here is to see anywhere where you have noticed the time it's above. So they're looking for lines, they're looking for marks here on the graph, okay? That's what you need to get some work of merit, okay? The question then is, for how long? So you're going to figure out this time, and you're going to subtract the 2. The answer you're looking for here is 2.3 seconds, and you were given an option of being plus or minus 0.25 out, okay? So again, that graph that I've just drawn there is not correct, okay? It's, you need to sketch that graph, and then you will need to fill out the rest of this. Okay. The next part here, find the derivative. Okay, so the derivative is another word for differentiation. Now, they've also used this symbol here, h-t. So both of those refer to differentiation. Okay, when we are differentiating, if I had, say, 2x squared and I differentiated that, you would bring down the 2 here and multiply it by what's in front. So you would get 4x and you decrease the power by 1. That was our kind of one of our basic rules. So here we've got minus 4.9 t to be squared plus 19.6t plus 1.85. Remember, the square is going to come down here and it's going to be 2 times minus 4.9 t, and then you're going to decrease this one by 1. So when I differentiate that, in the end, it's going to be so 2 times minus 4.9t gives me minus 9.8t. Remember, if you are differentiating anything, if you had said to differentiate 5x, when you differentiated, you lost the x. So if you differentiate 19.6t, it's going to work out to be 19.6. And if you had a number and you differentiated it, it always went to 0. So the final answer there is minus 9.8t plus 19.6. Very doable. Use the answer from part C to find the maximum height reached by the tip of the javelin. So we have an idea what the maximum height is from our graph, okay? But we're going to use calculus to say exactly what that is. So remember, for the max height, your differentiated equation is equal to 0. So all we're going to do is let the differentiated equation equals 0. So I'm going to do letters to one side, numbers to the other. Okay, and I get minus 9.8t equals minus 19.6. And of course, I'm looking for t. So I'm going to divide both sides by minus 9.8. And I'm going to get t is equal to 21.45 meters. It should look like that from your graph as well, but that's the exact measurements using calculus. The next one then says find H dash 3.5. So H dash is the differentiated version, and then 3.5. We are inputting 3.5 into anywhere we have a t. So again, really doable. So H dash is minus 9.8t plus 19.6. We got it from this point here. Okay, that was the question there. And so H dash 3.5. Okay, so instead of saying H dash t, we're going to write H dash 3.5. So it is not minus 9.8 times 3.5 plus 19.6. Okay, use your calculator to find out the answer there. The question also asks, to explain your answer, okay? So at this point, what is happening, okay? I think you will get a negative answer here. So imagine what that means for the javelin in regard its path. Volume B. Okay, there's a little bit of reading in this question, so let's take our time with it. A and B are two water tanks. At a particular time, tank A contains 100 litres of water and has been filled at a constant rate of 15 litres per minute. At the same time, tank B contains 1,640 litres of water and has been drained at a constant rate of 20 litres per minute. Let AT represent the volume of water in tank A after T minutes, and BT represent the volume of water in tank B after T minutes. Write down formulas to represent these in terms of T. So in terms of T means I'm going to have T in my answer. So if I look at the first one, tank A, it has 100 litres of water and it has been filled at a constant rate of 15 litres per minute. So every minute there's 15 litres and it says let T be minutes. So for this one here, guys, it's going to be, starts off with 100 litres and then for every minute I get 15 litres. So 15 T. Okay, so 100 plus 15t is the formula for that. BT, okay, remember it starts with 1,640 litres of water and it's being drained at a constant rate of 20 litres per minute. So it starts off with 1,640, but it's being drained, so it's losing water. So every minute it loses 20 litres, so minus 20 times t. So 1,640 minus 20t. Okay, work out how long it will take for the volume of water in tank A to reach 460. So when will the volume of water in tank A, which we know is this formula, equal 460? So letters to one side, numbers to the other. Okay, I'm going to let you finish that off. Work out how long it will take the volume in water in tank B to reach half of its initial volume. So initially it was 1,640. That was its volume. So half of that, 1,640 divided by 2 is going to be 820. So when is 1,640 minus 20t going to be equal to 820? So letters to one side, numbers to the other. Solve me for t, please. Okay, the last one. How many minutes will the volume of water take in both to be equal? So when does the formula in volume A so volume A, or the cylinder volume in A equal to cylinder volume in B. So when is 100 plus 15t equal to 1,640 minus 20t? Letters to one side, numbers to the other here. You're looking for 44 minutes here, so hopefully you get that. In this one here, you were looking for 41 minutes. And in this one here, you were looking for 24 minutes. So hopefully you were able to get all of those answers. Okay, the volume of water in tanks A and B are given below. At a particular time, tank A contains 100 litres and has been filled at a constant rate of 15 litres per minute. At the same time, tank B contains 1,640 litres and is being drained at a constant rate of 20 litres per minute. Complete the table below. Okay, so you have your formulas now. Your formula for this one here was 100 plus 15t. So if t is 10, it would be 100 plus 15 times 10, which would be 250. Okay, and you can see that that one's filled in. So you're using this formula for these ones here. And then for this formula here, it's 1,640 minus 20t. So using those formulas to fill in these bits here. Okay, the next question here says draw a graph. Guys, a graph is a plotted line. Okay, be very clear on that. It's not a bar chart, it's not a histogram, it is a plotted line. You are going to have to do one for A of t and one for B of t. So I would recommend doing them in different colours. So the very first one of A of t is 0, 100. So along as far as 0, up as far as 100. The next one is 10, 250. So along as far as 10, up as far as 250. So this one here is your tank A. Okay, I want you to fill that all out. I'll do the very last one for you. It's along as far as 60, up as far as 1,000. So here. So plot the rest of those points and draw that line. This one in here then, this is your formula. Okay, you're going to input these numbers into your T and see what answers you get out, and you're going to plot them. I would recommend plotting them maybe in a red line. So the first one here is 0, 1,640. So along as far as 0, up as far as 1,640. I'm just going to go there, and so on. So plot those two lines together. One cylinder is being filled, so we know that the volume is increasing. One cylinder is being drained, so we know that the volume is decreasing. So that's what our graph should look like at this point. Guys, the word graph is a plotted line. Sorry. Okay. Next one. Use your graph to estimate how long it takes tank B to empty and the volume of water in tank A at that time. So when you've got your graph done, when tank B is empty, obviously the volume is at 0. Okay, so you're looking to see how long that took. The examiner's looking for any marks you have on your graph to show that you were reading it here. Okay, so to get your attempt marks, they're looking for marks on your graph, actually where you have drawn in pencil what's happened. Use your answers from part A, part 1 to verify your answers to part. So you want to see at what times you're after figuring it out. Put those into your formulas and see does it work as well. Okay, the very last question. A different water tank can be completely filled using a certain hose pipe in 75 minutes. The same tank can be completely filled using a larger hose pipe in 50 minutes. Work out how long it would take to fill the water using both hose types. So this one here was quite difficult. I'll just give you the answers for this one here. You're looking for 82 minutes and 1330 there. So hopefully they're the ones you get. Now, this one is quite tricky, okay? Because you have to try and think about it in 1 minute, how long would it have taken? So in 1 minute, using the first hose pipe, you would have 1/75 of the cylinder filled. Using the second type in 1 minute, you would have 1/50 filled. So to figure out using both, you're going to add those two fractions together. Your calculator will do it perfectly. It'll give you 1/30. Okay, and what you're going to do then is remember that is 1/30. That doesn't represent the time, that represents the minutes. So the answer is 30 minutes here. That one was tricky, okay? Right, on to question number 9. 3 patterns in a sequence containing grey and white tiles are shown below. Draw the next pattern. Guys, people were not drawing the lines in between here, okay? If they are drawn here, that is important that you do them into your diagrams as well, okay? And then shading as well. Right, this one here wasn't too bad. Some people rushed it and got it wrong. You need to take your time here, okay? Counting the tiles and figuring out what the pattern is. Okay, so now we've figured out that this question is about patterns. I'm going to get my information on patterns opened on my log tables right now. Okay, so I've opened up my log tables. I've looked for sequences and series. I see it's on page 22. I've opened up page 22 of my log tables. There are two types of sequences here. The first one here is an arithmetic sequence or series, okay? And this is where there is a common difference between each of the numbers. So when you looked at your table that you just filled out, okay, I have it here, you will spot that each one of these is increasing by 1 each time, which means they have a common difference. So what we're going to do, C-O-M-M-O-N, what we're going to do here is we are going to look at the arithmetic sequences or series because they represent ones that have the same difference each time. So find a formula for grey tiles in the sequence, okay? So to find a formula, this is my formula that I'm going to use, t to the n. Remember, s to the n is if I want to find the total. So if I want to add up all of these numbers here, I'd be using this formula here for the sum. This is just the t to the n, my rule. So t to the n equals a plus n minus 1 times d. Now, hopefully you remember that a is the first term in the sequence and d is the common difference. So once you figure that out, what is the first term in this sequence? It is 3 plus n minus 1 times the difference. What is the difference in each of these? It is just 1. So it is going to be 3 plus 1 times all of this is just going to be n minus 1. And I can bring my numbers together. 3 minus 1 plus n. So my final answer here is 2 plus n. Okay, very easy to get your marks here. You just literally write down the formula and then to get more marks, you're filling in things that you know. Right, work out the number of grey tiles in pattern 40. So t to the n, I've just said, is 2 plus n. So t to the 40 would be 2 plus 40. So in that case would be 42 tiles. Find the total number of grey tiles in the first 40 patterns of the sequence. So you can see how this is a completely different question to this one here. Okay, it's saying, right, well, if you were to add up all the tiles in the first 40 patterns, what would it be? And that's when we use this formula here, the SN formula, okay? The sum of the series or the sum of the sequence. So let's write down the formula first and get some marks. SN is equal to n over 2 bracket 2a plus n minus 1 times d. Now, they're looking for the first 40 patterns. So we are looking for the sum of the first 40 patterns. So my n is 40 divided by 2 bracket 2a. My a hasn't changed. My a is the first number in the sequence. So 2 times 3 plus n minus 1 times the common difference, and in this case, it's still 1. Close the bracket. You can type all of that into your calculator, and you are hoping to get 900 at the end. So really doable question so far. Next one. Based on the pattern shown, complete the table of white tiles. Right, so we've got to do a little bit more adding here. So we've got 2, we've got 6 in the second one. In the third, we have 12. And then you'd be hoping to see if you can spot a pattern. So what are we going up in here? We're going plus 4 here, and then we're going plus 6. So our next one might be plus 8. And our next one then would be plus 10. That's what I'd imagine. So let's try it. We're going to have 20 and 30. Okay. Now, what you can spot here is that this is not going up in the same. So it says prove that it's a quadratic sequence. So if I was to write these numbers down. So I have 2, 6, 12, 20, 30. And if I was to look at the common difference between each of these, I've got 4, I've got 6, I've got 8, I've got 10. And then if I was to look at the second difference between them, you will notice that the second difference is all the same. And a quadratic sequence, the second difference is always the same. Assuming the pattern continues, the number of white tiles in pattern n, Wn of the sequence is given by this formula, n squared plus bn plus c. Find the value of b and c. If we are ever asked to find two values, I would always, first of all, think simultaneous equations. Okay, if we're asked to find an x and a y, or in this case, a b and a c. And so if that's the case, we need to have two formulas so that we can start to cross out and work out. So we're told n squared plus bn plus c is the Wn. That means the general rule. So what is the rule for the first term? So then that would be 1 to be squared plus b times 1 plus c. And if you look, the amount that's in the first term is 2. So I would have 1 plus b plus c equals 2, minus 1 on both sides, and I get b plus c equals 1. So that would be one equation. Then I could try 2. So 2 to be squared plus b times 2 plus c equals, and in the second one there's 6. So that would be 4 plus 2b plus c equals 6. And then I'm going to minus 4 on both sides. So 2b plus c equals 2. That would be my second equation. So now I can do simultaneous equations here. So with simultaneous equations, guys, remember you want to cross off your b's or cross off your c's. So I'm going to multiply the top line by minus 1. So that would give me minus b minus c equals minus 1. I'm not doing anything to my bottom line. I'll notice then that my c's cancel, and 2b minus 1b is b equals 2 minus 1, which is 1. And I take that answer and I substitute it into the top line. So b plus c equals 1. So it would be 1 plus c equals 1, minus 1 on both sides, c equals 0. Okay, so 1 and 0 were your final answers there. Okay, which means that my formula is n squared plus b times n, which is 1 times n, plus 0. Okay, the total number of tiles, grey and white, in the kth pattern is 226. So to get the grey and white pattern, you are adding your formula that you've gotten for the white tiles, and then adding the formula that you got for the grey tiles together. Okay, and then you want to see what number of those would give you 226. Okay, so my formula for the white tiles at the very start was n plus 2. And then my formula for the grey tiles that I've just done there is n squared plus n. All right, so equals 226. So let's do a little bit of working out here. If I add them both, I'm going to get n squared plus 2n plus 2 equals 226. N squared plus 2n. What I'm looking at here is it looks like I'm getting a quadratic. So I'm going to get minus 224 equals 0. So minus 226 on both sides. Okay. So this one can be a little bit hard. You could do minus b formula here. Probably that's what I would do, because I just wouldn't be great with the factors. But I can see here from the marking scheme that the factors were 16 times 14. So it would have been n plus 16 and n minus 14. So you're going to go n plus 16 equals 0, n is equal to 16, or n minus 14 equals 0, n is equal to 14. Sorry, there should be a minus 16 there. And obviously you're going to eliminate the inappropriate one. So we'll go with this one here. A vending machine dispenses different fruit juice drinks in a school cafeteria. In one such drink, the ratio of orange to apple to mango juice is 15:9:4. Work out the orange juice needed if the fruit drink contains 1.8 litres of apple juice. So anytime in ratio, if you are given the parts, you always find the total parts. So you add all of your numbers together. So if I was to add 15 plus 9 plus 4, I'd have gotten 28. And if the examiner sees that anywhere, you're going to get an attempt of 4. So 4 out of 10, so a huge amount. Now, we could do this a couple of different ways, but just looking at it, 15 is to 9 is to 4. If the apple juice went to 1.8, okay, what would the orange juice have gone to? That's basically what it's saying. So if the apple juice was to go from 9 to 18, it had been multiplied by 2. It's gone from 9 to 1.8. So there's a relationship there. It's actually multiplied by 0.2. And so all you can do there is you can multiply the 15 by 0.2 and you would get 3. And you could do the same for the mango, but we're not even asked that. So the amount of orange juice needed would be 3 litres. Another way you could do it using the parts is you could multiply 1.8 multiplied by 28 over 9, and that would give you 5.6, and 5.6 multiplied by 15 over 28 would give you the 3 litres. So just another method there, but I actually just thought recognising the equivalent ratios and breaking them down and multiplying them, it's actually what I'm doing with the second years at the moment, so not too bad there at all. The container which holds fruit juice in the vending machine is in the shape of a rectangular box with internal dimensions as shown in the diagram below. Work out the capacity, of the container. This is a cuboid, all right? Our formula for cuboid is not written anywhere in my log tables. It is expected that you know it. It is length by width by height. Okay, they're all in the same units, making this one nice and handy for us. So it is going to be 20 by 18 by 35, and your final answer here is 12,600 centimetres cubed. They've asked for our answer in litres. They've been really helpful and told us that 1,000 centimetres cubed is equal to 1 litre. So the answer here is 12.6 litres. Okay, so if you left it in this format, you would have lost just 1 mark here. How many litres of mango juice are needed to fill the container completely? So mango juice, we were given that information at the start. Let's do it again. 15 is to 9 is to 4. So this is my orange juice, this is my apple juice, and this is my mango juice. So in a ratio of 4, so 4 out of 28, if I was to break in my cuboid into fractions, and into 28 slices, 4 of them are going to be made up of mango juice. So it's going to be 4 out of 28 of 12.6. Anytime you see the word of in mathematics, you're just going to change that to a multiplied, and you should get 1.8 litres here. Orange juice costs €2 per litre, apple juice costs €2.40 per litre, and mango juice costs €7 per litre. Find the cost of the total vending machine. Okay, so we need to figure out, we know how many litres of mango juice is in it. Let's find out how many litres of orange juice is in it. So it would be 15 out of 28 multiplied by 12.6. And then how many litres of apple juice is in it? It would be 9 out of 28 multiplied by 12.6. So once we get those pieces of information, that's going to help us. This one here is going to be 6.75 litres, and this one here is going to be 4.05. So that's per litre. And once we have that now, orange juice costs €2, so we multiply that. Apple juice costs $2.40, so multiply that by 2.40, and then mango juice, there's 1.8 litres of mango juice, we're going to multiply that by €7. So your total here, what you're looking for is 35.82 in your total. Last part of the question, the fruit juice is sold as a markup profit as a percentage of the cost price of 85%. Work out the selling price of 1 litre. Okay, so it costs €35.82 to make the orange juice. If you are creating an 85% profit margin, you are going to find 85% of that. I always like to turn things to a decimal. So 85% of that is going to give you €30.447. So it costs this much to make it. They're adding on 85%, which means they are selling it for €65 and I think it works out to be €66 to 26 cent and 267. So looking at €66 and 27 cent. So that's how much it's costing to sell how many litres? 12.6. So we just divide it by 12.6 to figure out how much it would be per litre, and the answer is 5.2. So that's how much they need to sell each litre for to be making a percentage profit of 85%. Okay, into the very last section of this paper. A solution of acid marked 5% has a 5 centimetre cubed of acid per 100 centimetre cubed of solution. The solution is made up of measuring 5 centimetre cubed of acid and adding it to water, and then adding more water until the solution of the volume is 100 centimetres cubed. The solution is placed in a glass beaker in the shape of a cylinder. The beaker has a radius of 4 centimetres and a height of 12 centimetres. Find the capacity of the beaker. So volume. So you opened up your formulas in the log tables, you looked for your cylinder, all right, and there you found that the volume of a cylinder is pi r squared h. That means pi multiplied by r squared multiplied by h. In this case, it says give your answer to the nearest centimetre cubed. So you are typing your pi button into your calculator, multiplied by 4 to be squared, multiplied by h, which is 12. Okay, you're typing all of that in and you should get 603 centimetres cubed. The beaker is filled to its capacity with an acidic solution. Work out the volume of acid and the volume of water in the beaker. Give your answer correct to the nearest centimetres cubed. So we are told that 5% of this is going to be acid. So if the whole thing is 603, 5% of 603. So you're going to change it to a decimal, make sure you write it as 0.5 multiplied by 603, and that's going to give you 30 centimetres cubed. So that's how much of acid goes in. And then the rest is water. You can just subtract it, or you can find 95% of 603. And that's going to be 0.95 multiplied by 603. And the answer there is 573. So either way, it's to the nearest centimetre. So I've just done a bit of rounding there as well. And the very last question, a student needs exactly 35 centimetres cubed of acid for an experiment. Work out how much of the acidic solution is required. Okay. We know 5 is needed for 100. So let's find 1. So I'm going to divide both sides by 5. And that's going to give me, so for 1, we're going to need 20. So then to find 35, we're going to multiply it by 35. What I do to one side, I do to the other. And 200 times 35 is 700 centimetres squared.